Okay, everyone. Assalamualaikum warahmatullahi wabarakatuh, and a very good morning. Okay. Can you hear me? Just to check.
Yes, doctor.
All right. So first, please scan the attendance before we begin the session. All right. Okay. For Muslim, all right. Let's begin with Ulmu Kitab Al-Fatihah. So how are you? How are you, class? Everyone? Everything good?
Good, doctor. Fine.
Okay.
Far so good.
So far, so good. Excellent. Right. Let me share the. Let me stop sharing. All right. Let's recap what we have learned on the last class. Okay. Do you still remember what have we learned? Anyone volunteer, please? What have we learned?
What is liquid?
Okay. What is fluid? Okay. Next. What we have learned so far?
There are two types of systems,
Okay, good.
English system and the metric system.
Yes, perfect. Next. What have we learned? We learned about the basic of fluid, which is density. Okay. We learned about specific weight, which is gamma. Okay. Specific volume and specific gravity. And then we have a quiz, remember? And today, we continue on the property of fluid. Okay. Besides of density, specific gravity, we have another one we call as an ideal gas law. So, what is ideal gas law? Ideal gas law is any equation that relates to temperature, relates to pressure and density. Okay. So, the simplest and the best known equation, I believe all of you know this equation, yeah, of state is ideal gas law. What is the ideal gas law equation? Which is P V equal to R T. Or maybe you learn P V equal to M R T. Or maybe you learn P equal to rho R T. Right? So, you know that P is referred to pressure. V, small v here refer to specific volume. Okay. Specific volume. Or 1 over density, the same thing. R refer to the gas constant. And T definitely refer to absolute temperature. Okay. So from here, R The equation of R is basically R average over molecular weight of gas. Okay. This one, the R here, R average for the SI unit is 8.314 kilojoule per kilomole Kelvin. In terms of English unit, it is 1.986 BTU over pound mole Rankine. Okay. And not to forget, M is a molecular weight of gas. All right, that's it. So after we have learned ideal gas law, the temperature conversion, normally in exam, you must use the absolute, all right, which is Kelvin and Rankine scale. So, remember that we have two units, SI and English. For the SI, Kelvin, if you want to convert from any unit to Kelvin, okay, this is the formula. Temperature in Kelvin is equal to temperature in Celsius. You must plus 273.15. Okay, you will get temperature in Kelvin. Or if you have the temperature in Rankine, okay, you must divide with 1.8 in order to get temperature in Kelvin. Next is the temperature in English, which is Rankine. All right, which is temperature from Fahrenheit. You must plus 459.67. Or if you get from Kelvin, you must multiply 1.8. Multiply with temperature of from Kelvin in order to get Rankine temperature. So that is the conversion. And next we learn about the viscosity. So what is viscosity? Viscosity is a measure of fluid resistance to shear or angular deformation. So resistance to flow is a property of viscosity. For example, motor oil has high viscosity and resistance to shear. Ammonia, on the other hand, has a low viscosity. So the basic rule, as the temperature increase, viscosity of fluid decrease. However, the viscosity of all gases vice versa or decrease. Okay, remember the viscosity of this is symbol of viscosity of the gases increase with increase of temperature. However, the viscosity of the fluid decrease with increase of temperature. Let's say we have a plate. All right. Let's say we have two plates. All right. Imagine that this is the plate, top plate, and we have the bottom plate. All right. And at the middle of the plate, we have the liquid or we have the fluid. Whatever lah. We have the oil, we have the water, we have the gas. Okay, all that kind of fluid. So here is the distance. Here is the distance, which is y. And then suddenly, I want to move the top plate at the right section at the velocity u. So what happens if we have the fluid? We have the fluid in the middle. What do you think? Can you give a comment here? What do you think?
The fluid will hold the plate.
The fluid, yes. Definitely the fluid will hold the plate at the bottom. Okay, that means this is the motion of the fluid. Okay, this is the velocity of the fluid. You can see here, the velocity of the fluid at the bottom, this is fixed, yeah. The bottom is fixed. However, at the top is moving. At the bottom, this plate stick to the fluid. So the fluid at the bottom stick to the plate, it is not moving. So what do you think of velocity here? What is the velocity here? Is equal to
0.
0. What do you think of velocity at here? It is? What is the velocity here? Do you have any value? Yes, correct. It is maximum. Alright. The velocity here is maximum. U is a maximum. Alright. So, from here, you can see the most important point that I will highlight. At boundary, particle fluid stick to the wall. That is why the fluid velocity relative to the wall is 0. While for the top plate, U is maximum where it is in contact with the upper plate. From here, the velocity profile form the velocity variation. So here we call this, the whole this thing, this one we call as a, we call here is a velocity profile. Okay, this is a profile. Okay, this is the profile. Okay, what happen if we have another case? For example, we have the plate, we have the bottom plate, and then we have the fluid in between, but the fluid is moving. The fluid is moving to the right, as well as the plate here. The plate moves to the right. So what happened to the velocity profile? Is it the same, linear or non-linear? What's the shape? What do you think, Fong Yi Ka, Tan Bin Ji? What will be the shape of velocity profile? Any guess?
Maximum in the middle.
Maybe. Let's see. Let's have a look. All right. Previously, it will be like this. Okay, this is the previous without the net of fluid motion. And we have a motion because this is y. The fluid, the velocity profile will be like this. Okay, so now the velocity profile is in the form of parabolic shape. So this is the velocity profile. Okay. This profile change because of the viscosity. Okay. The viscosity of the fluid from the bottom will influence, for example, this is particle. Okay, this is another particle. This is another particle. Okay, imagine we have the fluid particle here. Okay, this particle move. However, this particle move slowly. Why move slowly at the bottom compared to the top? Because of the viscosity resist. This move freely. However, this second one resist the flow. The top, the number 3 also resist the flow. Become like this. Become like this. Okay, now you understand what is the viscosity. Okay. So for linear case, all right, please listen carefully. For the linear case, We are referring to the first one, linear case. The shearing stress between any thin sheet of fluid is found using, this is symbol here. This is symbol of shearing stress equal to force over area. Okay, you must be wondering why we have force over area while the pressure also force over area. Can you see here? The tau, this is symbol of tau, tau force over area. However, pressure also force over area. What's the difference? Any guess? Why there is a difference between the P and tau? The formula is the same. What's the meaning behind?
Direction of the
Direction
force.
of the force. Correct. So this is the plate. For example, this is the plate. All right. The force for the tau is like this. Okay, this is the force from the tau. However, for the force for the pressure is like this. Okay, remember the force, the pressure coming from the force is perpendicular. Must be normal to the plate or normal to the force. However, the force from the shearing stress must be parallel. That is what we call a shearing stress. Shear, you mean you shear something, it is normal. It is parallel. Okay. You know that shearing stress force over area. Another equation is viscosity U over Y. Okay, or viscosity du over dy. This is the difference. Du over dy means the change in velocity. That means like this, yeah. Okay, tau equal to mu tau du over dy. That means dy is a different here. For example, this is y1, this is y2. So, du refer to y1 minus y2. And then u refer to here. The velocity at here. u1 refer to u2. So, u1 minus u2. So, that is what du over dy. Okay. This equation we call as a Newton equation of viscosity. So here mu, okay, we refer to the viscosity. Okay, the unit is in the SI unit is Newton second over meter squared. However, for the English unit, it is pound second over feet squared. Okay, we have another category of viscosity. We call as a kinematic viscosity. This one we call as the dynamic or absolute, the same thing. Okay, remember viscosity can be categorized into two, dynamic and kinematic viscosity. So what's the unit? What is the formula of the kinematic viscosity? The nu, this is symbol, equal to dynamic viscosity over density. So here, the dynamic viscosity is the unit is feet squared over second or meter squared over second. So now you can see the difference. What is the difference here? What is the difference between those viscosity? Class, can you judge any difference between kinematic and dynamic? What's the difference? Please respond. What's the difference?
There are no force involved, sir.
Okay. Basically, the difference is you can see the density. The dynamic viscosity, the kinematic viscosity involve density. Involve this one. Okay, while dynamic viscosity don't involve the density. So that is why the dynamic viscosity, okay, doesn't affected by pressure. While the new here affected by pressure. Strongly, okay? Strongly affected by pressure. Why? Okay, let's draw the cubic. Okay. Let's draw a cubic. And then let's have the density formula equal to mass over volume. So what happens if I push the cubic in all direction? What do you think of the density? Increase or decrease?
Increase.
Okay, why increase? Please explain in terms of equation. Why increase? Because volume decrease. Perfect. Okay, we press with the pressure, the volume decrease, while the density increase. That is why the kinematic viscosity directly affected by pressure. Okay, because of rely on the density. Density change will change the kinematic viscosity. So, lastly is the Reynolds number. Okay. Reynolds number. Okay, that Reynolds number is a parameter that correlate with viscosity behavior. Of fluid. Okay, fluid have the behavior. One of the behavior is resistant to the flow. We call it as a viscosity. So the unit is, the formula of Reynolds number is rho VL. This is velocity. L is a characteristic length over dynamic viscosity. Or if you push this one to the bottom, it will become VL over rho, right? Mu over rho. This one is basically VL over mu over rho. Dynamic viscosity over with density is, you can see here, refer to nu. Okay, or kinematic viscosity. So based on what you have learned, what the Reynolds number, the kinematic and absolute viscosity, you learn about the velocity profile, okay, between the plates. Okay, you learn the viscosity, temperature conversion. Let's have a quiz time. Okay, let me share. Okay, let me share the screen. Okay. Everyone, please wait ya. Okay. Let's have a quiz, please. Okay, please go to www.menti.com and use the code here. Okay, I will post in the chat, or you can click the link here. Okay, for those get the highest score will obtain the extra mark. Okay. Okay, we have 60 students, 61. Okay, good. We have 733. Please be ready, yeah. Score well. Who will be the lucky winner? All right. Okay, please please join all. Okay. All right. Now, let's start. Okay, we have 79, 80. Okay, please join fast. Quickly. Please go to the www.menti.com and use the code here. All right. I believe all of you have joined. Let's start it. Okay, this is the quiz here. Answer fast to get more points. Any equation that relates to is called the equation of state. Faster. One. Time's up. All right. So the answer is pressure, temperature, and specific volume, as well as pressure, temperature, and density. Let's see who will be the winner for this question. Okay, Lee, number one. The faster. Congrats, Lee. Okay, you have 4 questions to go. Okay, Devil, Ko, Wei Ming, Nuha, Riz, Ginny, SH, Adriana, Ardini, Tan, Sal. Okay. Please, guys, you need to move. You need to fast to get the question fast. Right? Question 5. Ideal gas law is? Okay, what is it? Okay, 3, 2, 1. Time's up. Okay, we have to answer, yeah? PV equal to RT or P equal to density RT. Okay, let's see who will be the ranking. Who is the faster one? Let's see. Okay, Sal, the faster one. Okay, Sal got the right. The top ranking, yeah? 1848 point. Okay, good. Well done. Okay. We have Nuha, we have Bai, Andrew Lee Han Hoi. Good. Question 3. Ready, guys? Conversion of temperature in Kelvin. Remember, we have conversion into two conversion. Okay, what is it? Maybe we have one answer, two answer, three answer. All right, thumbs up. Okay. Okay, none of you choose 1/8. Okay. Okay, who is the faster one? Who is the winner? Oh, the faster one, Ko Wei Ming. Okay, congrats. Okay, congrats to Sal. Good. Okay, we have Livid. Okay, Shy. Okay, next. The next last two question. Answer fast, please. Viscosity is what? All right. Viscosity is a fluid resistance measurement. Okay. Who is the faster and the top one? Let's see. Okay, we can see Adriana, I think. Okay, Sal, still number one. Okay, congrats. And then we have Tan. Tan, the faster one. Adriana, number two. Okay, Ginny, come to top 10. Okay, good. Finally, who will score the winner here? Okay, as temperature increase, viscosity of what? Maybe we have 1, 2, 3 answer. 3, 2, 1. Finally. Okay. Viscosity of fluid decrease or viscosity of all gases increase. Let's see who is the winner. Oh, congratulations, Sal. Congrats. Okay, Sal. Okay, Sal, please introduce yourself. Please, guys, class, please congratulate Sal. Okay, Sal, please introduce yourself and then explain your strategy to win the quiz. Okay, who are you? We want to know you.
Yes, doctor.
Okay, please introduce yourself.
My name is Nur Salsabila binti Maridi.
Okay. How do you win the game? Do you win the quiz? Please tell us your strategy.
I have no strategy, I think.
Okay, no strategy. Are you sure? Maybe you have written the note, you have studied before the class. Humble lah. Maybe because your friend also want to know your strategy, so your friend also can apply. Any strategy? Or you focus?
Focus only sebab
Sebab apa?
Saya tak study lagi pun sebelum ni. Baru je. Baru je buka hari ni.
Okay. Okay. Okay, Sal, congratulations. Please put your full name, your section and the metric. I want to include you as the winner for this quiz, yeah?
Okay. I put at the chat box lah.
Okay. Okay, class. You may try again. Okay. No any cheat. You don't have any cheat. Okay. Okay, next. Okay, please. I want to know your name and then your metric, your section, please. I want to include you as a winning score for the winner. You will obtain the mark, yeah. Congratulations. The winner. May I know your name? Can you put in the chat box? Name, the metric number, and then the section. Many want to learn from you, Lee Chi Ying. Okay, Sal, please put your full name. Your full name, Salsabila. Nur Salsabila. Inti PA 20EM 0221 section 13. Okay, good. Okay, class. The last part, before we end our class, I would like to have the breakup session. Okay, please look at the. Let me share you the screen again. Okay. We're gonna have the activity. Okay, this is fine. We're gonna have the activity. And click the link that I will share later on. You are group for 11 to 14. Okay. Okay, go to the link. I will send to you now. Okay. Enter the link here. The Jamboard Google link. Okay, please join the link. And what do you see here is a listing of grouping. Okay. I will create 12 grouping for you, 12 session. Please refer to your own session. Okay, please do not move here. You can view only. Even though you are the editor as well, but you need to see your own group. For example, Fong Yika, okay, you are session or group 1. Okay, for those haven't got any group, please let me know. Okay. So, based on your group, okay, you know already your group, yeah? I will create the 12. Oh, too many people. It's okay. Is it because of the internet? Too many people, yeah. Okay, cannot open the link. Okay, you need to continue. Go to the external site and open the link. I believe I can. I can open the link. Okay. Okay, it's okay. It's okay. For this part, I have created the group here. The discussion within 20 minutes only. Okay, everyone, when you look at the WebEx interface, go to the bottom. It's okay, it's okay. Just follow my instruction. Okay, you look at the interface of WebEx. You can see the breakout session. Okay, when you see the breakout session, I have created 12 breakout session. All right. So, okay, please do not join, yeah? Please listen to me first. Okay, when you look at the breakout session, and then you will join the breakout session based on your group. Okay, if you don't know your group, let me share you the screen. Okay. Okay, wait, yeah. Okay, can you see the screen? Please remember your group. Okay, this is the grouping. Okay, please look at carefully. For those unable to join the Jamboard, please look at the screen and identify your grouping. After you have identified your grouping, please after this go to the breakout session based on your grouping, and within 20 minutes appoint the leader and discuss with your team, getting the unified answer, getting the same answer together and solve the question. Okay. All right. So that is the instruction. Okay, now after you have joined your team, the moderator or the leader should share the screen and then go to your dedicated group. You can see group 1, group 2, group 3, and start to discuss and solve together with your team. That's it. Okay, do you have any question?
Doctor,
Yes.
my name have uh, my name have repeated in the group list. So,
Okay, choose the first one.
thank you, Doctor.
Okay, I don't have. For those haven't got the name, please let me know. Okay, for those, please. And you don't have a name, please let me know. Rizky, yeah. Rizky Zulin. Okay, Rizky Zulin, please go to group 2. And Muhammad Aris, please go to group 3. Fadil, please go to group 4. Khalid, please go to group 5. Julian, please go to group 6. Shazrul Nizam, go to group 7. Okay? So far until group 7. Okay. Please go now and start discussion. Go to the breakout session and choose your session. Session 1, group 1. Okay? Please go now. I will monitor. I will go one by one to your group and see your discussion. Okay? Appoint the leader.
Sorry, doctor.
Okay, for those haven't the group, you Vanessa. Okay, go to group 8. Nani go to group 9. Okay, that's it. Okay, now faster, please go to your own group now and have a discussion. The time is running. Okay, Nani, not 12 people. We have 12 group. One group maybe will have 5 to 7 people. Okay, I don't want one group so many people. I want a good discussion. Okay, one leader and then one 4 team member discuss together how to solve. Okay, be creative. Divide the task. Step 1, who is the leader? Step 1, who will do? Step 2, who will do next? And then you can solve within 20 minutes. I can see some of you still in the main section lah. Shafika, Timothy, please go to your dedicated room. Okay, some of you still in the main session. Please go to your breakup room. Snol Salsabila, Alessandro. Irshad, do you know how to go to your own breakup room? Go to the bottom section, click the breakup session and join the session. Your friend already have a discussion. Okay, please contribute your knowledge, your idea, because this activity gonna help you later on for the long-lasting memory. Okay, everyone, please go to your room now. Zarif, Daniel, Shafika, Raphael, please go now to your dedicated room. Are you listening or you already left the session? Okay, Ong Si Jun need link for group 2. All right, everyone. Are you there? Can you hear me? Okay, so now the breakout session already complete and finished. Let's see. I will pick randomly and choose the question, choose the group. And then your team need to have a volunteer and discuss. Okay, from this group, I can see that I want to choose the least answer. Okay, the complete answer I won't choose. I will choose the less work. The less and the highest work. Okay. Okay, it seems that group 11. Okay, who is the volunteer for group 11? Who is the volunteer? Okay, who is the leader? Please, the leader for group 11.
Yes, doctor. We actually haven't picked a leader because we were a bit confused about the question.
Okay. So
Well,
can you volunteer explain?
yes, I can do what I have done. But should I
Okay.
write on the I'll just so I use the equation that you give us now.
Okay.
The shear stress, there's two equations. The shear stress equal F over A, and the other one is the viscosity du over dy. So I will equal F over A equal the viscosity over du over dy. So u is the velocity. So we'll have final velocity is it's given on the equation is 20 feet per minute. So we'll change the minute to seconds by
Okay.
dividing by 60. So you will get 0.33 feet per second. So that's the U2. U1 equals 0. And now we'll have to find Y. And Y is the distance between the blades. So it's mentioned the distance between the blades is 1 inch. And the 1 inch, and there's at the end of the question, there's 0.33. If the blade is 0.33 from the surface, so we assume that we will minus 0.33 from 1 inch, and it would be 0.67. And this 0.67 will convert to feet because it's inches, and this by dividing by 12, if I'm not mistaken. So you'll get 0.5583. So after getting all this, so you will get the force by the 0.33 divided by 0.5583 multiplied by the
So what is the force 1 and force 2?
force one. I only got 0.014895.
Okay.
Maybe I think my friend also got a different answer. Maybe my answer is wrong.
Okay, it's okay. Let's see other group. Okay, now I can see group 5. Please volunteer. Okay, everyone, now go to example group 5, yeah? Okay, I have problem to share the screen. Please go to group 5. And group 5, please explain your solution. Who is the volunteer, the leader, or any volunteer for group 5? Any volunteer, group 5, please? Please, quickly. The leader, please. The group 5 leader.
I cannot see the Jamboard, Doctor.
Oh, okay. Any of your group can see the Jamboard?
Yes, a few.
Okay. That one can see, please explain to us.
Wait, Doctor. I try to share.
Okay, good. Okay, please share.
Can you see, Doctor? Hello?
Hello?
Can you see my solution? Our solution?
Okay. Nani cannot see, yeah?
Wait, I will try again.
Okay.
It seems like I cannot share. I don't know why.
Okay, everyone, can you go to, it's okay, can you go to page 5? Can you go to group 5 and you may start share.
Doctor, I'm from group 9, so I'm just gonna share for him.
Okay, it's okay.
Doctor, I think I also cannot share because I need some permission like that.
Yeah. Okay, it's okay lah. Just explain what you have done.
Doctor, I am sharing. Can anyone see my share screen?
It's okay, it's okay. Please go to group 5,
Alright.
Jamboard. Okay. Um. Okay, can you start explaining group 5? Group 5, please.
Okay, Doctor. I will try.
Okay,
Okay,
please start.
first of all, the
Mm-hmm.
question asks us to get the force required.
Okay.
So, based on the formula, shear F over A,
Mm-hmm.
we change it to F equal to shear
Mm-mm.
multiply with A. So
Okay,
now
good.
we already have A and we don't have shear. To get shear, we use formula. Wait, we use formula viscosity
Okay.
times with velocity divided with y.
Okay, good. Then?
From the question, we know that the plate, the apa, there is plate in between two plate. The distance with upper plate from the thin plate is 0.33 and
Alright.
distance between tiny plate with below plate is 0.67.
Okay,
With
good.
that information, we
Mm-mm.
use that to calculate shear.
Okay, good. Then?
Shear for the upper plate is like shear 1 is like we did, then we
Okay.
get 0.0764, and
Okay.
then for the shear for the below plate shear 2 we get 0.0394. That's it lah. And then we add together the
Okay.
from plate 1
Mm-mm.
and plate 2, we
Okay.
get the total shear. Then we use that total shear to get the
Mm-mm.
force. That's it.
Yes. That's perfect. Okay, a class, very good. Okay, this is the correct answer. Congratulations, group. Example 5, group 5. For those got the same answer as group 5, I can see group 1. Okay, do you have the same answer 0.463? Any group?
Yes, Doctor, from group 9. We also have the same questions and we also have the
Okay,
same answer.
congratulations, group 9. Okay, group 10. Alright. Okay. Nothing. Only group 5 and group 9 get the right answer. Okay, basically very simple. First you go to page group 5, you draw the figure. After you draw the figure, in between the plate we have the thin sheet plate. Okay, we move the thin sheet plate 20 feet per minute. And then 0.33 is a distance from the top and 0.67 at the bottom. You know that the total distance is 1 inch. So 0.33 minus 1 inch minus 0.33, you will get 0.67. So from here, you will assign the shear stress. I draw here, yeah? This is shear stress 1. Okay, and then this is shear stress 2. Based on this shear stress, you calculate tau 1 and tau 2 using the equation. I believe you use the equation tau is equal to...
Doctor,
Yes?
can you share the screen?
I have a problem to share the screen.
Oh, because I cannot go in the Jamboard. It's too many people.
Okay. It's okay. Try to listen. Okay, this is solely for the technical error lah. I will share you the complete solution at the note. Okay, please listen carefully. Yeah. After you get the shear stress tau 1, tau equal to viscosity du or tau equal to mu over u over y. Okay, you put in the information, you put in the value, you get the tau 1 and tau 2. From the tau 1 and tau 2, you need to convert into force. So force equal to tau multiply with area. So tau 1 multiply with area, which is 4 feet. And then you get the force 1 and force 2. So the total force must be the combination of the top force and the bottom force, which is force 1 plus force 2. Finally, the answer is 0.463. Okay, that is the final answer. Okay, I try to share again. Okay, Nawal will stop sharing content as you start sharing. Okay, I try to share, but I have a problem with my Webex here. I unable to share anything. Okay, finally lah. Let me explain a little bit the final one. About the vapor pressure. Okay, after this we end our class. Vapor pressure is considered a closed container in a fluid. So what is a vapor pressure? Vapor pressure basically evaporation start causing a vapor to be trapped above the liquid surface. So the vapor exert a pressure on the surface of the liquid. For example, you have the container filled with the water. Okay, because of the environment temperature, it will evaporate the water. So the evaporation of water will exert the pressure to the water surface. So that is what we call a vapor pressure. Okay, I think that's all. Never mind. I will give you the complete solution and fill up note in the e-learning. Yeah. Please, after this, look at the e-learning and do the revision. Okay. That's all, class. Okay, thank you so much. Okay, thank you, Nani. Thank you, all of you, for participation in the class. Okay, I end my session with Assalamualaikum warahmatullahi wabarakatuh and good luck and all the best.
Thank you, Doctor.
Thank you, Doctor.
Waalaikumsalam.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor, for the explanation and everything. Very
Thank
good.
you, Doctor.
Thank you, Doctor.